Hello, welcome back. So in this episode we are going to discuss about the software development life cycles. As you know, previously we were discussed or we were learning something about the software processes. So fundamentally there are four software processes: the software evaluation, the software development, the software validation, and the software evolution. So this sets of process will be discussed in detail here in software development lifecycle. So we can say that software process is the categorizations of each steps of software development life cycles, or in the other way you can say the software process represented in detailed way in a software development life cycle. Here we have, this was the software development. In the software development, this was the software processes. So the software specification is already with the requirement determination. The software development already related with the software design and the software implementation. The software validation already associated with the testing mechanism, and finally, due to various reasons, the software may evolve. So this was in the previous episode, but here we will discuss the software lifecycle in detail. In short, each software process represented in a software development lifecycle. We can use different kinds of software development lifecycle. There are several stages which are represented differently but with the same output. For the time being, we prefer this software development life cycle. We will conduct the feasibility study, the market analysis, the requirement determination, the software design, testing, and the software maintenance. When we define software life cycle, or software life cycle is also it is a stage-by-stage process. Each stage has their own outputs or deliverables. Each deliverable will be input for the next stage, or the first stage, or one output of one stage output of the software life cycle may be input of the other, or it will be the milestone for the other process. So simply you can say software lifecycle is a sequence of different activities that takes place during the software development process. Maybe they will have different kinds of deliverables. Let's begin to discuss each software process or software lifecycle activities. The first activity is already the feasibility study, or we can determine the development of the proposed system will be cost effective, as well as can we develop under the current budgets at the same time using the current technology and hardware and software technologies. So the first part of the software lifecycle is the determination of its feasibility. If the software is feasible, so as we said always, we can proceed forward, or we can investigate the markets. In the market investigation or in the market analysis, we have to check whether the potential market is there for our software product. Don't forget that in professional software development, a software product will be produced for certain business purpose or for certain business perspectives. So we have to check whether the market is available for there or not, if there is a potential market. And next to that, we have to determine the requirement. So requirement determination is one of the basic steps in a software life cycle activity. So requirement determination means understanding the application or the business domain. So we'll gather various requirements through observation, task analysis, interview, through joint application development or JATs. So this simply requirement is the future order constraint in the system. So it's better to determine those particular requirements. Requirement already determined at requirement engineering part of the software development process. When you say requirement engineering, we are going to find, check, identify the necessary requirements. So during the requirement, we have to determine what functionality the software should contain. We have to determine the service which is provided by the software. As we all know, the software will provide any kinds of services or unintended services. So we have to check those particular services. For that matter, we have to gather different requirements from the user, or understanding the operating environment of the software, and communicating with those business domains, so business users, we have to check whether the requirement is are there or not. So simply we have to gather the requirements. Plus, we will analyze the domain. In this case, it is better to understand the business domain. We have to know what kinds of tasks are there, what are the structures of the system in the business domain, or there is a business modeling. We have to understand the business very well. So, domain analysis related with the business modeling or understanding the business tasks and the structures that is common to this problem. The other thing, if you do that, it's better to plan how we conduct the software development process. In the project planning part, determining how to develop the software, there are different kinds of tasks here. The first one is already cost analysis, determine cost estimates. So since we have different requirements, also we have different kinds of tasks. Each task needs a budget as well as needs a human resource that needs a cost. So we have to analyze those particular costs, how many cost it needs, it is estimation. So it's better to estimate the costs. Plus we have to schedule, we have to allocate time for each activities and for each tasks. So building a schedule for the development is one of the project planning part. The other thing, the software product must meet its own product quality. So we have to going to measure the software quality assurance. That means in the software production there are different kinds of processes, and there is also the project, and there is also the product. So we have to measure these three things, as well as not only the software product, we also measure the quality of the process and the quality of the project, the software project. So we have to check, we have to assure how we are going to control, manage, and plan the quality of the software. And during delivery, the defect is not already advisable. Software defects never be advisable during the software delivery and deployment. So it's better assure the quality of the software. So at the planning, we have to plan how we are going to assure the software qualities, i.e. we will have a quality plan, we'll have a quality plan, and we will also a mechanism to control the qualities, and finally we'll have the quality assurance mechanism. The quality assurance mechanism. The other thing is we have already work breakdown structure. So we have here the system. So the system will have different subtasks. So we'll understand, we'll determine the subtasks necessary to develop the product. Maybe using a divide and conquer or using a top-down approach system development mechanism. We have to know the various subtasks that is already in the system development. So what is the benefits of this subtasks? Maybe if we understand the tasks very well, we have to allocate time, resource, budget as required. The other thing is the software designing part. In the software designing part, we are going to determine how the software should provide its functionality. Keep in mind, we were planned and we know that we were determining the functionality of the software. Here in the software designing part, we will determine how the software should be provided its functionality, how we are going to design the structure of the system, the abstract design, the interface, the component, and so on designs. Previously we were discussed about in designing parts more in detail, but for the time being we'll stick how we are going to design the architecture of the system. The architecture of the system already indicates that how the structures of the system looks like, how each component interact with each other, how each component accessed by the user. So we have the architectural design. The interface design will be indicates that the system will have different kinds of components. Each component interact one with the other, so this interaction will be considered as one system interfacing with the other. So we have also designed what kinds of interaction between each system components. That is, we call it already interface designs. What we design here is also the detailed design. The detailed design already related with the algorithms of each component. It is related with the data structure at the same time with the algorithms of each component, is because when we identify the structures, maybe there's several two or more structures or components, but these components implemented or built later on in the next stage. So that means the implementation stage, it's better to design their algorithms. For example, if you have 3 components, each of 3 components must have already the algorithms. So the designing part is just look like this. Keep in your mind, after finalizing the designing part, based on the software specification and based on the software design, we have to implement or we're going to program the software. In this part already you have the implementation part. During the implementation we will use one or more programming languages, or we have to select different kinds of coding standards, coding procedures. In short, the implementation means developing or building the software. This is the fundamental development process where the software product starts, or the software product will be generated here according to the design and the requirement part. Maybe the developers may use different programming language for coding, such as C++, Java, C#, Python, and so on. So in the implementation part, every designing will be converted software products. So don't forget that in the implementation part we will have the software product. So the software product must be testing against the system specification and the user's expectation. So in this part we are going to determine whether the software has error or correct according to the system specification and the user's expectation. Simply testing means that executing the software with data to help ensure that the software works correctly. When you say works correctly, or we conclude that the software is working correctly if we fulfill or meet the software specification and the user's requirement. So there are various testing in this regard. The first one is already the unit testing. So this kinds of testing already it is testing by the original developer. So during the programming part, every software developers will test the output of each code, or they will test each component score. So if they pass, if each component passes the test, or if it is working okay, then they will proceed to develop the next component. So it is a component-based testing, or simply it is testing by the developer, the original developer. So this testing already unit testing. Not only we have conduct the unit testing, but also there is integration testing. So during the integration testing, two or more components can be integrate together, and there will be a test, so we can test each component if they are working together or not. So all in all, each component will be combined together, then we will test each components together. So this kinds of testing already is called testing during the software integration. If testing integration is the internet test is okay, now there is a system-wise testing. This system-wise testing is, as the name indicates, it is already the system testing. So when you say the system testing, the tests that we conducted in the environment that matches the operational environment. So testing can be conducted a certain environment which looks like the operational environment. So when you say the operational environment, at the end of the day, we will deliver or we will deploy the software. So those software will be deployed on those particular users' machine or in the users' environment. So we have to check whether the software testing against that. So this is the final test regarding the system production. So the rest of the tests will be alpha testing and beta testing. So the alpha testing will be conducted by the developer side. The customer will test by simulation at the same time using the actual data. The actual data is already originated from the customers, so the simulated data is already the data which is simulated by the system developers. But the customer will test the software or the software product by its own data, but it is as the customer's, sorry, it is at the developer side, or it's already as a developer's machine. If this test is will be okay, or it has a green light, so the next test is already beta testing. this is testing by the customer at the customer side. We are ready to deploy the software at the customer's machine. So with the real data, we're going to implement it on the customer side. Then the customer will use the software product as well. If there is any gaps or errors, there is also a feedback. The customer will raise his comment, and the software developer tries to adjust or correct those particular errors or those particular defects. Unless and otherwise, if the customer is satisfied, then the system will be implemented after testing the customer satisfaction. So this testing the customer satisfaction is also called acceptance testing. So we have to show whether the customer is accepted or not, or with the software product, or we have to check whether the software is satisfying the purchaser's need, or whether we have to check those expectation requirements. And finally, we have regression testing. The third thing, if the customer accepts the software product, now it is ready to deploy the software into the user's machine, or we have to provide the customer with ineffective solutions. So we believe that the real world problem, or the problem that was raised previously, is already finalized. So this part of the software development lifecycle is delivery and deployment. Here we have three tasks: installing or making sure the software available at the customer operational site. That's we are going to deploy the software, training the users to use the software, and finally we have any help desks for any situations that the customer is, will provide the help or will assist them. So this is the software delivery and deployment part. The last phase of any software life cycle is already maintenance. This maintenance is the process of modifying, updating, and changing the software as well. So updating and improve the software to ensure continued usefulness in one or the other way, or vertical or horizontally. The software may be maintained. The other thing, maybe it will be modified and changing, or to improve the quality of the software, or to improve the needs of the customer. So it's always done after product has launched for several reasons, including improving the software overall, correct issues or bugs. If there is some defects or errors, we are going to correct those particular defects and bugs, or to boost the performance and more. We can make a maintenance of a software. So this maintenance is part of software evaluation. Basically, there are four fundamental software types of maintenance: the corrective maintenance, the preventive, the perfective maintenance, and finally we have the adaptive maintenance. So this is all about the software development life cycle. If you need more, please subscribe, share, and like this YouTube channel. For the time being, thank you very much. So in short, to finalize this, every software process will have a place in a software development cycle. See you again.